Hi, everybody. My name is Alan Paul Noel Newme, and I'm presenting my final project of Advanced Data Modeling Spring 2026. And I select my dataset from Kaggle, and it is called ICE Detention Trends, October 2008 to 2nd Jan 2025. And let us see how it goes and how it predict the for the whole world that detention is going on, which is showing. So we can see here the daily population, books in per day, books out per day, mean, median, and standard development, and minimum and maximum, which we can see here. And if we see here in the presidential era comparison, the first one is Obama, the second time is Trump, which he won election for the first time and second time, and between that, President Joe Biden was there. So we can see the net flow here, 8,947 during Obama time, and minus 24 might be in the first term of Trump, might be because of the COVID. Let us find out, and let us see here the Trump which is going on, that is 22,383. That is the net flow. So we can see here the table from 2028 to 2025. We can see the net flow, total books out, total book in, book out, average booking. All these are all which was recorded from the Kaggle. And the central research that which I use for study is how do daily booking inflows and outflows affect changes in ICE detection population levels over time. That is what I am trying to find out. That is the research that I'm doing. Now, the question focuses on understanding the operational dynamics of detention system by examining how admission books in, books out, together with prior population levels, shape daily detention counts. The goal is both explanatory, identifying key drivers of population change, and applied, uh, providing insight useful for forecasting and policy evaluation. Now I use uh, the code of Python to find out exactly what it goes. So the first one is the code for MLR. MLR is for the which can fit for multiple linear regression model. And the second one is the Bayesian regression. You can see here the codes for the multiple linear regression, and we can see the second part is for the Bayesian regression. Here it continues still here, and the residuals we can see here also from the Python, where they are putting out uh, the lag, which was residual. That is lag 1 to 24, which is showing. And we can see the key aspects of the data set. The data sets consists of daily ICE detention records spanning multiple years. We can see back again here in, yes, we can see with each observation representing one calendar day. And key variables include the total detention population, that is daily population, midnight population, and daily flow measure, that is the book in, book out, like uh, which was allowing the population to be analyzed as a dynamic system driven by inflows and outflows. The data are longitudinal, consistently structured, numeric, and sufficiently large, well over 500 observation we can see, making them suitable for regression and time series analysis after standard pre-progress processing, such as creating lag variables and calendar controls. And after we have seen all the code and the residuals, I use the models of multiple linear regression, in short MLR, and a Bayesian regression. We can see here the actual versus predicted, and the multiple linear regression serve as a transparent baseline model. That's why I use that estimates the average effect of daily booking out, and prior population levels on current detention population. Its trend lies in interpretability and ease of comparison across predictors. And Bayesians are regression that uses the same models structured but incorporates weekly informative priors, allowing for regularization and explicit uncertainty quantification through posterior distribution and credible intervals. This makes the Bayesian models especially valuable for policy relevant interpretation, where understanding uncertainty and the range of plausible effect is as important estimates. So Bayesian uncertainty bands are here. We can see how it goes. Start from the middle line and it goes down and it comes up, and it was going more from 2021. It goes up in 2019, maybe right after the pandemic, and now the trend is still going on. And the multiple linear regression R to 0, that is equal to 0.168, and which shows the modest predictive ability correcting correctly identifying that net booking in minus out dry population. However, it struggles with structural breaks like the COVID-19, which I have said, which was dropped in 2020, and 2025 it surges again. So Bayesian for me, Bayesian regression with automated relevance determinations, we call it ARD. It is a little bit, better than any other models. That's why I use this one. And ARD priors effective traits all features as noise on this data sets. Its R2 is equal to like 0 is scientifically appropriate. So the model expresses high certainty or uncertainty rather than overfitting 18 observation. That is what it says. So this is a feature, not a failure. It is a feature, not a failure. Might be for the government. It is observation or experimentation. So both models confirm that ICE detention population is driven by policy decision and external shocks that are not fully captured by booking flows alone. So additional features like budget allocation, enforcement priorities, court orders would likely improve predictive accuracy for either models in either MLR or Bayesian. But I think Bayesian's regression models, are more effective, which I have learned so far. Thank you so much, everybody. Thank you.